There'll be some problems where you'll want to utilize the property of logarithms, which can be helpful often, and use those properties to help us rewrite functions. And this is a good example. This problem here is a good example of when we'd want to do that. And that process of using logs, or taking the log of both sides of your equation and then proceeding from there, is called logarithmic differentiation. I should point out that it's often used when you have variables in the base and the exponent. Right, so you can see in this example here, there's a variable in the base, x, and there's a variable in the exponent because it's cosine of x. What a lot of students think is that they'll think, oh, okay, this is easy. Y prime equals, I'm just going to bring down the cosine of x times x to the cosine of x minus 1. And then if they really think they're clever, they may even times by the derivative of cosine of x using the chain rule. But that's not correct, because that's applying the power rule, which only applies when you have a variable in the base and a number in the exponent. But this time we've got variables in both spots. So we're not going to do that because it's wrong. So what we're going to do first is we kind of want that variable in the exponent to come down. And one way to do that is to take the log of both sides. So you can use any log you want. I guess I'll use ln. And that's the first thing we want to do. So ln of y equals ln of x to the cosine of x. So we'll say that's like our first step. Take the ln of both sides. And now what this allows us to do is use the property of logs, which is one of which is that we can move that cosine of x down. So this means ln of y equals cosine of x times ln of x. And we're in a good position now because we have a tool for finding dy dx at this time. It's implicit differentiation. So we'll take the derivative of both sides. And the derivative of the left side is the derivative of ln of y, which is 1 over y times dy dx. And now the derivative of the right side, that's a product, so we're going to have to use the product rule. So let's leave the cosine alone, times the derivative of ln of x, which is 1 over x. And then we'll add that to the derivative of cosine, which is negative sine, leaving the ln of x alone. And now we're almost done. We just need to solve for dy dx. So we're going to multiply both sides by y. So dy dx equals y times cosine of x. We'll write that as cosine of x over x minus sine of x times ln of x. And now pretty much we're done, except it would be great if our answer was all in terms of x and not y and x. So we go back and look at what y is equal to. Y is equal to x times cosine of x. So dy dx is equal to x to the cosine of x times cosine of x divided by x minus sine of x times ln of x. And there's our answer. Alright, so if we kind of mark the steps, the first step I wrote is take the log of both sides. I'm going to put this here as step 2. In step 2, what we did was we differentiated implicitly with respect to x. And then the last thing we did was we solved, I'll point actually to here. Right, we solved for the dy dx. And then the last thing we did was we just substitute to make your answer in terms of x. Right, only in terms of x. So there's a technique called logarithmic differentiation. It can come in handy, again, when you have variables raised to variables. It comes in handy in other situations too, but for now, this is the main, I think this is the main type of problem you'd want to use it for.